Lerp is a terrific tool for blending two numbers, but we often want to blend two colors to create a gradient or a changing color, and processing gives us lerpColor to do it. lerpColor is just a convenience. We can do everything lerpColor does just with good old regular lerp. Let's see how to do that, because that shows us exactly how lerpColor does its job and why it's such a handy routine. Suppose I have two color variables named C1 and C2, and I want to blend between them. The first thing I might do is pull the color apart into its red, green, and blue components. These three lines pick out the red, green, and blue of C1 and store them in floating point variables named R1, G1, and B1. Then I'll do the same thing with color 2 and store its red, green, and blue in variables R2, G2, B2. Now I have these 6 variables. I can call lerp 3 times. Once to blend R1 to R2, and I'll store the result in a floating point variable called new R. Then I'll blend G1 to G2 and store that in new G. Then I'll blend B1 to B2, store that in new B. And finally, I'll put the color all back together again by calling color with new R, new G, new B, and saving that in a new color variable called new C. So all I have to do is pull the colors apart, lerp the individual red, green, and blue pieces, and put it all back together again. If I don't want to type these 10 lines of code and create all these variables, all I have to do is type lerpColor once. lerpColor takes 2 color variables, C1 and C2, and a float, V, and gives us back a new color that is blended from C1 to C2. I did all of this in red, green, blue. You may remember from our earlier discussion of color spaces that processing gives us a second color space called hue, saturation, brightness, or HSB, and that colors blend differently in the HSB space. Well, that's fine. We can do the same thing in HSB. Let's go ahead and do that. I'll take my color C1 and pull it apart into hue, saturation, and brightness, which I'll save in H1, S1, and B1. Then I'll do the very same thing for color 2, and then I'll call lerp 3 times to create a new H, a new S, and a new B by blending the hues, the saturations, and the brightnesses. Then I'll put the color back together again, but remember the default color mode is RGB, so we have to tell processing when it reassembles the color, do it in HSB mode. We do that by calling color mode with the special argument HSB, all in caps. Now we're in HSB mode, so when we call color with these 3 floats, processing knows that they are hue, saturation, brightness, not red, green, blue, and it creates the appropriate color. As always, I strongly recommend going right back into RGB immediately so that you never get confused and you never forget what color mode you're in. If you don't want to type all this code, of course we can use lerpColor. All we have to do is go into HSB mode, call lerpColor, and go back into RGB mode. And that will blend color 1 to color 2 in HSB space. To lock this all down, let's look at it visually. Here's our input range, 0 to 1, and we have a floating point number somewhere between 0 and 1 called V. Then we have our output range that is generated by 2 colors, the color S and the color E. Here's sort of an orange and a blue. Processing takes all this stuff and finds the corresponding color in the color range and returns that. So we would write it this way, lerpColor SEV. Notice that the arguments are in just the same order that they are for lerp, only now S is a color and E is a color, and what comes out of lerpColor is also a color. The final argument to lerpColor, V, that's still a floating point number as before. This is what we would do in RGB, and of course, as we saw, if we want to blend in HSB, first we call color mode HSB, we do the call to lerpColor, and then I recommend coming right back to RGB. Let's see what these blended color ranges look like. Here's a sketch that you may remember from our discussion of color spaces. We'll look at it again because it demonstrates just what lerpColor produces in different situations. In this little sketch, you can see the RGB and HSB blending at the same time. The big horizontal bar near the top of the window is the RGB version, and the horizontal bar just below it is the HSB version. On the left and right, we have two big vertical bars. Those are my starting and ending colors. And you'll see that the bar on the left-hand side has a little triangle under it, and that tells me that when I move the RGB sliders at the bottom of the screen, I'm adjusting that color on the left. Notice that the RGB blend has the typical characteristic of going through a muddy or gray color along the way, while the HSB blend has its typical characteristic of moving through a whole bunch of different hues as it goes from one color to the next. The gradations I'm showing you are exactly the output of lerpColor. I'm just drawing a whole bunch of little rectangles one next to the other, each one filled in with a color returned by ColorLerp, either in RGB at the top or HSB at the bottom. As the two end colors become more alike, the two different blending styles produce results that are also more alike. We blend in RGB with a straight line, but we blend in HSB with a spiral. As we saw, the colors that spiral passes through depends on the relative positions of the start and end colors. Here, the starting and ending colors are in one orientation in the HSB cone, but if I tweak the starting color just a little bit, it pops over onto the other side, and suddenly we now pass through lots of intermediate hues. As we discussed in the video on HSB, this is just the nature of moving around in the HSB color cone. Whether you choose to blend in RGB or HSB, lerpColor is a great one-liner. You can use lerpColor to create gradients on the screen, of course, maybe creating a sky that goes from dark blue to light blue. You can also use lerpColor to change the color of something over time. If you base the value of V, say, on frame count, then as frame count gets larger and larger, V will get larger and larger, and the color of whatever you're drawing on the screen will move from S to E. Now, officially, the value of V should be between 0 and 1, and that will always give you a color between S and E. But you know what? You can use any value you want for V, and you'll get something back. It may be weird, it may be unpredictable. So if you like having strange and maybe unpredictable things happening in your imagery, try values of V outside the range 0 to 1. Those times when you do want to control the colors you're getting back, make sure V is always within that range. As we've seen, we can do everything lerpColor does with just good old lerp. But lerpColor lets us blend colors in just one line, so it's simple and clear and easy to read and understand, and those are good things.